we're going to look at reducing and multiplying rational exponents. Now, this first one here is just a regular old fraction, and remember, in order to reduce something, you need to have a common factor. So as I look at 12 over 18, I'm thinking to myself, what's the common thing that I could pull out of both of these? And I could pull out a 6 from both of these expressions, because 6 times 2 would give me 12. Excuse me, 6 times 3 would give me 18. Then I can cancel my 6's out, and I would be left with 2/3. We do a very similar process when we're reducing rational expressions. Now notice when I had the 6 and the 2 up here, they had to be multiplication. Right here we have a little bit of a problem. A common mistake is kids want to cross out the 2 and the 2. That is not allowed because we have a plus sign here. Whenever we're reducing, we always have to have it in terms of multiplication. So what we need to do is we need to look if we can pull anything out. And as I look at the top, I can pull a 2 out of that top expression, and by doing that, I'm going to be left with 1 plus 3x, and then on the bottom, I still just have a 2. Now that I have it in terms of multiplication, because it's 2 times this quantity, now I can cross out my 2's, and I would be left with 1 plus 3x. Here's another example. I've got 5 times 3x plus 2. Now this one is already in terms of multiplication because it's 5 times this quantity. So I can go ahead and reduce my 5 and my 25. That will reduce down to a 1 and a 5. So I would have 3x plus 2 divided by 5. Now I still want to check if I can pull anything out of the top because I might be able to reduce it down again. And out of the 3x plus 2, there isn't anything common I can pull out, so then I would have to be done with that one also. And the last one for there. I cannot cross out these x squareds because my numerator is not in terms of multiplication yet. So I have to basically factor it. I have to try to pull out a monomial. And as I look at my x squared and my x, the biggest thing that they have in common is x. So when I pull that x out, I am left with x plus 2, and on the bottom I have x squared. Now I've got my numerator written in terms of multiply because it's x times this quantity, and on the bottom I have x squared. Well, I'm going to rewrite that x squared as x times x, and now I can go ahead and cancel out my x's. They would cancel down to a 1, so I would end up with x plus 2 divided by x. And again, I cannot cancel these x's out because the numerator is not written in multiplication anymore. Hey, here's the first one we're going to look at. Looks quite a bit different than the ones we just did, but it's still the same process. I have to get my top written in terms of multiplication. Well, this one I cannot pull out a monomial, and there's x in 2 spots, so this is when we have to factor. You can use any of those factoring processes that we have learned so far. I'm going to go ahead and just regular factor it, so I'm going to have a 2x and an x. The plus 15 tells me that the signs match. The plus sign up here tells me they match as plus signs. So I'm going to have plus and plus. And now my multiples of 15 are 1 and 15, and 3 and 5. So this is where you might have to get into maybe a little bit of the guess and check, trying to figure out how we're going to get down to that 11. I'm going to try 3 and 5 in here. Now I have to check it by foiling it because if I don't have this right, it's going to cause problems in the rest of the entire problem here. So when I foil this out, I'm going to have 2x squared plus 6x plus 5x plus 15. And when I do 6x plus 5x, I get plus 11x. So I end up getting what I need. Now I can go ahead and look at if I can cancel anything. My numerator is written in terms of multiplication. I've got 2x plus 5 times x plus 3. And notice on the bottom I have x plus 3. So I can cancel these out because they're identical. So the x plus 3 acts as a family. If I want it to be gone, I have to completely cancel it with another x plus 3. All I'd be left with then for this problem is 2x plus 5. I would only have a 1 left on the denominator, and since that's all we would have there, we don't need to write it. Alright, another one. Same type of thing going on here. I've got to try to factor out the top. So I'm going to use x and x. The minus sign tells me that the signs are different. So I'm going to have a plus and I'm going to have a minus. Now my factors of 12 are 1 and 12, 2 and 6, 3 and 4. I'm going to use the 2 and the 6 because they're going to get me to a negative 4. I still do need to check it by foiling. So I'd have x squared minus 6x plus 2x minus 12. Negative 6x plus 2x is negative 4x. And we end up getting what we need. Now the bottom, I can't cancel anything out because nothing matches. But what you need to recognize is this can be factored also. It is one of our shortcuts that we have in our flip books. So if you go to the two-term column, it's a squared and it's a minus sign. It's a difference of two squares. So I need to rewrite it as x squared minus 2 squared. So it's going to factor into x plus 2 and x minus 2. Now I've got an identical family that I can cancel out and reduce to ones. So I would be left with x minus 6 over x minus 2. And again, I cannot cancel these x's out. I cannot reduce the 6 and the 2 because they're not written as multiplication. Okay, here's a third one. Go ahead and pause the video and see what you come up with for this third one. Alright, on this one, I'm assuming you had a little trouble getting the top factored, and that's because it doesn't factor out nicely. The bottom would factor into x plus 3 and x minus 2, but since the top isn't going to match any of that, we can't reduce it, so this one would have been done. Again, I cannot reduce the x squareds because it's written in terms of addition and subtraction instead of multiplication. Okay, here's a fourth one, so go ahead and pause the video again and see what you come up with for the fourth one. When you factored the top, you should have gotten x minus 6 and x plus 1. And on the bottom, it's that difference of two squares pattern again, so it's x plus 1 and x minus 1. I've got the x plus 1s on the top and on the bottom, so they will go away. And I am left with x minus 6 divided by x minus 1. Okay, now we're going to look at multiplication, and we generally want to reduce before multiplying. So if I were doing this multiplication problem here, 2/3 times 6 over 11, I'm going to go ahead and reduce the 6 and the 3 first, and I'm going to reduce them by 3, so I would be left with a 1 and a 2. Then I'm going to multiply straight across, so 2 times 2 would give me 4, and 1 times 11 would give me 11. So general rule of thumb is reduce before you multiply. Here's our first example. Now I can reduce anything on the top with anything on the bottom. Since it's a multiply problem, I can do that. I'm going to just start with the regular numbers. So I'm going to reduce the 6 with a 2. So that would give me a 1 and a 3. I'm going to reduce this x squared with that x squared. And now this y to the third and the y to the second. Y to the third means I have 3 of the y's up here. Y to the second means I have 2 y's. So I can cancel out 2 of those with these 2. And I'd be left with a y yet. Or you could use your rules of exponents. Since it's a division problem, I subtract my exponents, and 3 minus 2 gives me a 1. So far on my first fraction here, I'm left with 3y over 1. Now my second fraction here, I've got 10 and 18. I'm going to go ahead and reduce those both by 2. So I would have a 5 and a 9. The x doesn't have anything on the bottom to reduce with. The y to the fourth. I'm going to use my rules of exponents this time. 4 minus 2 would give me 2, so I'm left with a y squared. I'm going to put all of this together now and see if there's anything else I can do. So when I go across the top, I have 3y, I have a 5, I have a y squared, and on the bottom, oops, I missed an x cubed there. And I still have an x cubed on the top. On the bottom, I am left with a 9, it looks like. I can put a lot of different things together here. I'm going to keep reducing though before I do my multiplication. I can reduce my 3 and my 9. Now you might not have noticed that right away because the 3 was on top of the first fraction and the 9 was on the bottom of the second fraction, but since one's on top and one's on bottom, you can still reduce them. So I'm going to reduce them by 3. And then I'm going to combine my y's here. They are on the same level. They're both on top, so I follow my rules of exponents. This is y to the first and y squared. My rule says I add my exponents, so I'm going to have y to the third. And I don't think there's x's anywhere else, so I'm going to go ahead and rewrite this yet. So I've got a 1 here. I've got y to the third, because I combined those two. I have a 5, and I have an x cubed, and on the bottom I have a 3. Going to check again. Let's see. My 5 and my 3, those don't reduce anymore, so I'm going to leave them. I'm going to move the 5 to the front, though. The y, this is the only place I have a y, so I can't do anything with that. And this is the only place I have my x. So it would stay like that. Here's another one. On this top one, I cannot cancel out this 4x and that 4x because my top is not written in terms of multiply yet. So I need to see if I can factor this. And as I look at this, I notice I can pull out a 4x from both terms. And when I do that, I'm going to be left with 1 minus x. And as I look at the top of my next fraction, it's not written in terms of multiply, so I've got to factor that out also. I'm going to have an x and an x. I'm going to end up with minus 2 plus 3. FOIL that out to check it. And down here on the bottom one, I've got to factor that before I do any canceling because it's not written in terms of multiply. So I'm going to have an x and an x. That minus 3 tells me my signs are different. I'm going to have a plus and a minus. Factors of 3 are 3 and 1. FOIL that out to check that also, and it will work. So now I've got everything in terms of multiply. This bottom I don't have to do anything to because it's already in multiply. It's a 4 times an x. So now I want to look if there's anything I can cancel. Well, I've got a 4 that can cancel with the 4. Now the 4x is not actually a family. They are still individuals because it's multiply between them. If this was a plus sign or a minus sign in between there, then I would have to have the identical expression. So for right now, I can just go ahead and cancel my 4 with my 4. As I keep looking, I've got an x here that I can cancel with the x there. I've got an x plus 3 and an x plus 3. And now you might notice that this expression right here, 1 minus x, is almost identical to that, except for they're in the wrong order. What that means is I need to pull out a negative 1, because when I divide these both by negative 1, I'm going to get negative 1 plus x. If I rearrange that, that's the same thing as x minus 1. Now I can cancel out my x minus 1 with my x minus 1. And on top, I'm left with a negative 1 here. And I have an x minus 2 left. And on the bottom, I just have a 1. So I would really have negative 1 times x minus 2 for my final answer there.